Hey guys, let's do another concept support video. This one's on solving proportional word problems. So let me just go over some basics of proportions real quick. So remember, any proportional relationship is always going to be some constant times an input equals an output, because the ratio of y over x, or output to input, is always the same throughout the entire relationship. It stays constant. Every proportional relationship has to have the idea that it starts at 0, 0. In other words, if the input is 0, the output is 0, because remember, there's only multiplication between input and output. Something times input equals output. So that means that if you times anything by 0, you're going to get 0, right? So it means that x and y are both going to be 0 at the same time, right? So let's kind of go through and see what happens here and see if we can answer some word problems. So Pamela drove her car 99 kilometers and used 9 liters of fuel. She wants to know how many kilometers she can drive with 12 liters of fuel. She assumes the relationship between kilometers and fuel is proportional. So she's thinking she's got like basically an average fuel consumption rate that's consistent and constant. All right. So if that's the case, and we're looking at this, we got to figure out what we're going to put as our x and what we're going to put as our y. Now, generally with a car, you input gas and you output miles, right? Because input's what you put in, what you start with. We call this the independent variable. And then output's what you end up with. That's called the dependent variable. So you basically input your fuel, right? Depending on how much fuel you input in the vehicle, that's going to generate how many miles the car can travel. So input, fuel, output, miles, or in this case, kilometers, distance. So let's go through and fill this out and see how it looks, all right? So the first thing I would do here is I would think about what my categories are going to be. And just like miles per gallon, the distance is going to go on top, and the liters of fuel are going to go on bottom. So I'm going to put liters of fuel on bottom. So I'm going to put fuel here, liters of fuel on bottom. And then we're going to put on top, we're going to put kilometers, right? So there I'm going to put just kilometers on top, right? So I don't want to confuse you guys with K, so I'm going to write kilometers. Okay, so you've got kilometers on top and liters of fuel on bottom. So remember, your input then is going to be the fuel, right? You're going to put the liters of fuel. So that'll be fuel and liters, right? And your output is going to be the kilometers. Okay, so now that we understand kind of what our categories are, our unit rate would be where x is 1, right? Where input is 1. So in other words, how many kilometers you can travel for 1 liter of fuel. Okay. So it says here there is 99 kilometers for every 9 liters of fuel. That's our relationship. So our unit rate would be just to divide top and bottom by 9. And what we can see there is that we would get 99 divided by 9 is 10. And then you've got 9 divided by 9 is 1, right? So now we have our unit rate. And our unit rate would be that you can go 10 kilometers on every single liter of fuel. So it would be 10 kilometers per liter. That would be our unit rate. And they're saying that, okay, she wants to go 12, she wants to know how far she can travel with 12 liters of fuel. All right, so all that means is that we're going to change our fuel from 9 to 12. We know our unit rate is that we're getting 10 kilometers per liter of fuel. So for 12 liters of fuel, we're just going to times that by top and bottom by 12 to get our equivalent ratio, right? So 10 times 12 is what? 120. So if you're getting 10 kilometers per liter, you're going to get 120 kilometers that you can travel in 12 liters. And you guys can see that that ratio stays the same throughout. So if we were to fill out the rest of our table, we would see that you've got, when we have 9 liters of fuel, you can travel 99. When you have 12 liters of fuel, you can travel 120. And this would be kind of the table. This would be the reasoning for it, and this would be your equation. The equation would be, in this case, y equals 10x, right? Because for every liter of fuel, you can travel 10 kilometers, and so on and so forth. All right, so the correct answer here is 120. It says not quite right. What did I do wrong there? Pamela drove her car 99 kilometers and used 9 liters of fuel. She wants to know how many kilometers she can drive with 12 liters of fuel. She assumes the relationship between kilometers and fuel is proportional. All right, so 99 kilometers, 9 liters of fuel. Divide top and bottom by 9. Oh. Oh, guys, you have to divide correctly. It's early, huh? Look at me. It's not 10, is it? Silly, Mr. Fisher. You must be tired, Mr. Fishback. It's not 10. It's 11. 9 divided by 9 is 11. And now we can do it correctly, because now we can times top and bottom by 12. And then we get 12 times 11, which is 120, plus 12, which is 132. And now we'll have the correct answer. That's pretty funny. I forgot how to divide. 132 divided by 12. Okay, so there's your ratio. Now it should work. 132. All right, I got it. Yay. I know how to do this. I just don't know how to do division. Okay, so let's do the next one. Ted likes to run long distances. So let me erase this stuff here. I go back in time, clear everything out for you guys so you have a nice clean example for the next problem. All right. There we go. All right, so next problem. It says Ted likes to run long distances. He can run 20 kilometers in 95 minutes. He wants to know how many kilometers he will go if he runs at the same pace for 285 minutes. So at the same pace tells you it's proportional. It's like basically an average speed that he's consistently running at. And so we've got a choice. Do you want X to be kilometers or minutes? Well, which does it make more sense? Does it make more sense to have kilometers per minute or minutes per kilometer? I think generally you'd be thinking about this in terms of kilometers per minute, because that's like a speed, right? How fast is someone going? Well, how many kilometers per minute are they traveling, right? Like miles per hour. So because that's probably the way I would normally think about it, I would put kilometers on top, and I would put minutes on bottom. Which means that if I ratio kilometers per minute, that means my y is going to be kilometers, my x is going to be minutes. So that means that here it's going to be minutes and kilometers. Okay. It says that 20 kilometers in 95 minutes. So that means you can do 20 kilometers in 95 minutes. And then he wants to know for 285 minutes, how many kilometers can he travel? So he has 285 minutes now, and how many kilometers can he travel? So this is our unknown, all right? So you can set up our ratio that way. And so then in this case, we got to find our unit rate, right? So we know that when x is 95, the y is 20, right? 20 kilometers in 95 minutes. And so now we want to divide top and bottom by 95 to get our unit rate. How many kilometers can this person travel every single minute? So 95 divided by 95 is 1. And 20 divided by 95 is whatever that happens to be. So 20 over 95, you can divide top and bottom by 5 and get 4 over 19. So it looks like 4/19 would be the amount of kilometers per minute. So then he's going to be doing this. So the equation would be y equals 4/19 times x. That's your equation. And now we just want to figure out for 285. So this is 4/19, guys. So we want to figure out for 285, what would that be? So if we input 285 minutes, we just multiply this by 285, basically, right? So you're going to get y is equal to 4 over 19 times the 285 over 1. And in this case, I don't think there's any common factors there between 19 and 285. So I would just do it on a calculator if it was me. I don't think it's going to take a lot of time doing skills you probably already have. So I would just do 4 times 285, get the answer 1,140, and then divide it by 19. And you get 60. I guess I was wrong. I guess it does cancel. I didn't see it. So anyways, you get 60. And so what that tells us is that that this would be 60 here. And let's just check and see if that makes sense, right? So if this is accurate, before we put our answer in, because we don't make a silly mistake like last time, the ratio must always stay the same, right? So what that means is that 20 over 95 is going to be the same as 60 over 285, right? Y over x is equal to y over x. Let's just check it. 20 divided by 95 is 0.21, blah, 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 blah. And 60 divided by 285 is 0.21, blah, 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 blah. So yeah, it works. So the ratio stayed the same throughout. The unit rate is 4/19 of a 419 kilometers per mile, per minute, I should say. And that's our equation. We've got all the things we need. This time we'll get it right. So how far will Ted run in 285 minutes? He will go 60 kilometers. All right, let's erase all this stuff and start again. Let me pause the video. All right, so now I'm back. Rachel earned $34 in 4 hours at her job today. She wants to know how much she could earn tomorrow if she worked 10 hours at the same hourly rate. So the same hourly rate means proportional. She's earning the same amount per hour. So now we can go through and fill this out. You generally want to think about how much she's earning per hour, right? That's her earnage rate, right? Pay rate she has. So you would think about it that way. And if you're thinking about a pay per hour, basically, you're looking at the output to be dollars, pay, and the input to be hours. So you'd be looking at the output to be dollars and the input to be hours. So that's kind of how you'd set that up. The unit rate would be how much she's getting paid every single hour, right? So how much money she gets every hour, right? That's the unit rate. How many y's for every one x? And that's also your multiplier, right? Your k, your constant proportionality, same as we have here. So we know that she's getting $34 in 4 hours. So she gets $34 every 4 hours. What we want to know is how many dollars she gets every single hour. That's a place to start. So we would divide top and bottom by 4, and we're going to get our answer here. So 4 divided by 4 is 1, and 34 divided by 4. 4 goes into 34 how many times? Well, 4 times 7 is 28. 4 times 8 is 32. So we're looking at 8, and let's say 2 left over, so 8 and 2/4, or 8.5. So she's earning 8.5 or $8.50 per hour. So that's her salary. Her salary is $8.5 every single hour. It says how much will Rachel earn if she works 10 hours? Okay, so now our input changes from to 10, right? And so now we can just say that our equation y equals 8.5x is now going to be something we're going to use. Plug in a 10 for x, we get an output of what? Well, 8.5 times 10 is 85. So that's going to be $85 for every 10 hours she works, right? And now we have all the things we need. So basically, she got $34 in 4 hours. She gets $85 in 10 hours, and she gets $8.5 every hour. And if you were to check it real quick on a calculator, you just do y over x and make sure it stayed the same. So 85 divided by 10, 8.5. 34 divided by 4, 8.5. And of course, 8.5 divided by 1 is also 8.5. So the ratio of y over x always stays the same. Hence, we have the correct understanding. So this is going to be 85. All right, and now I'm going to pause it and reset the stuff. All right, so this one says, Stan's cookie recipe makes 24 cookies and calls for exactly 384 sprinkles. He is wondering how many sprinkles he will need to make 60 cookies. He assumes that each cookie will have the same number of sprinkles. So I think it makes sense to input cookies and output sprinkles, right? How many sprinkles per cookie are you going to need? Okay, so that's what I would do. So when I'm setting this problem up here, I would input the cookies, so input cookies, and output sprinkles. I can't really write, but there you go. Let me see if I can write that a little more carefully for you guys. Input cookies and output sprinkles. It's kind of tough to write this small. Let me zoom in. Whoa, that's better. Okay, let me try that again. Make this nice and pretty for you. Cookies and sprinkles. Little trick for all you guys using a tablet. Zoom in. Okay, and that means that our output here, y over x, is going to be the same thing. So it's going to be, you're going to be inputting the cookies, and you're going to be outputting the sprinkles. So basically, sprinkles per cookie is your unit rate. Okay, now we can zoom back out. We got this nice, beautiful table to work with, and we're good to go. All right, so what do we know about our relationship so far? What we know about our relationship so far is that 24 cookies takes 384 sprinkles. So when you have 24 cookies, it's going to be 384 sprinkles. All right, so we can fill out this table here. 24 cookies requires 384 sprinkles. Okay, and to get the unit rate, how many sprinkles per cookie, we're going to divide top and bottom by 24. That giant 1 keeps the ratio the same, but gives us the answer we're looking for, which is the unit rate. So 24 divided by 24 is 1. 384 divided by 24, let's just save some time. 384 divided by 24, 16. So that means that you're getting 16, this person's needing 16 sprinkles for every single cookie, 16 sprinkles per cookie. So that's the unit rate, all right? Which means our equation is going to be y equals 16x, right? Where x is cookies and y is the number of sprinkles, right? For every cookie, you need 16 sprinkles. And then you just solve the problem. So how many sprinkles does Stan need to make 60 cookies? Well, if you're making 60 cookies, obviously we're going to use more than double the amount of cookies, so more than double the amount of sprinkles, right? But exactly how much? Let's find out. So it would just be y is equal to 16 times the 60. And that's just going to be 60 times 10, which is 600. And 60 times 6, which is 360. And so add it together, what do you get? 960. So you're going to have 960 sprinkles that he'll need for 60 cookies. So you could check it before we put it in so don't get that error message again. So 384 divided by 24, 16, should be the same exact value as 960 divided by 60, 16. Bada bing, bada boom, our constant stayed constant. We're good to go. So now we can put our answer in confidently without making any silly mistakes like I made the first problem. There you go. And that's it. Hope that helps, guys. That's how you do these problems.